Hello and welcome to a new video in the C# for Beginners playlist. As we saw in past lessons, the usual way to deal with classes is to create copies of them called instances and to customize these instances to your liking. And in our case, we created two instances, my book and your book, and both of them have different titles. However, there are many times when it would be nice to be able to use a class without instantiating it first. Like for example, when we write something at the console, we say console.writeLine. We don't say first console, my console equals new console and then my console.writeLine. And even more so, while in this case using an instance would be just an inconvenience, there are many times when using one is simply not possible. So let's see what I'm talking about. We have a class called book that contains a numeric property called stock, which we can initialize to 100. And then we have a cell method, which simply decrements this property. Then we create two instances of type book, we set their title and we call the sell method because we want to sell them. Then afterwards we print the stock value again. So let's see what the value is, and surprise surprise, for both of them is 99. Why? Because again an object has state, which is individual, and behavior, which is common. The behavior, the action to be sold, is common to all books. All books can be sold, and the action to sell does the same thing for all of them. It decrements the stock property. But the state is individual, so make no mistake, when I said book my book equals new, this instance's stock property was initialized to 100. But when I said book your book equals new, this instance's stock property was also initialized to 100. So now we have two instances, each of them having a copy of the stock of 100. So no wonder that when we called sell on my book, it decremented that and is now 99, and when I said your book.sell, it also decremented, but that instance's stock property, and now that instance's stock property is 99. This is partly what is hard for beginners of OOP to grasp, but it's actually quite simple. If I'm an engineer and I design a blueprint for a car that specifies 4 chairs, and then I create 10 instances of these cars, and for 3 of them I remove 1 chair, I only remove a chair for these 3 instances. The others are not affected because they are copies, they are independent, they are individual. This is also what happens here. The book blueprint specifies that the stock is 100, but then when we create instances and we affect them with the sell method, we only affect the individual instance on which we call the sell method, not the others. So if I were to call sell on my book again, the stock of my book is now 98. Because I called sell twice on my book and only once on your book. But this makes the stock property quite useless, isn't it? Because if you don't have a global shared stock, how do you actually keep track of every single book that you are going to sell, no matter how many instances you create? And obviously it's not feasible to call sell on every single instance that you ever create just to keep the stock properties in sync on all the instances. This is where the static keyword comes in. All we need to do is put the static keyword on the property, and now this property is no longer bound to any of the copies, to any of the instances. Instead, it belongs to the prototype, to the manuscript, to the blueprint, to the book type itself. So it's unique because the prototype, the manuscript, the blueprint is unique. If you don't know what I'm talking about, go see the video about classes. If I try to run it, we will get compiler errors. Member book.stock cannot be accessed with an instance reference. Qualify it with a type name instead. In normal language, this just restates what I just said. The stock property belongs to the book type itself, to the blueprint, to the manuscript, not on any instance, on any copy. So like we do here, my book.stock. That's why we get errors. And it even makes sense so. That's why it says member book.stock, because it belongs to the book type itself, not on my book, not on your book, not on any other instance that you might have. So if I modify to access it like the compiler suggests us to, we obtain this. Well, of course it makes sense now why this belongs to the book type itself, thus is unique, because in both cases we wrote the same thing, is the same property. So if I run it now, the stock will be 97 for both cases because again it's the same property. But take a look at this. We called the sell method 3 times, 2 times on an instance and another time on another instance. So even though I called the sell method on different instances, the stock property that it decremented was the same for all of them. It's the same property, it's unique. So let's see some of the quirks of the static members. When you instantiate a class, memory is allocated and initialized for all its fields. So for example, if you have a title instance string field that is directly initialized with some value, that memory is allocated and populated the moment you create an instance of that class, because it's an instance field, it belongs to that instance that you create. However, for static fields, that is not the case. Since they are unique for each data type, you'd expect them to be declared and initialized before anything in your program gets executed, even before main gets called. But that's not the case for performance reasons. And in fact, static fields are declared and initialized at some undetermined point in time, but one that is guaranteed to run before you try to use them. So for all intents and purposes, by the time you try to use a static field, it will be declared and initialized. This also implies that static members cannot access instance members. So let's take an example. And we get an error that states an object reference is required for the non-static field, method, or property book.title. Again, translated, this means that title is not static, which means it's an instance property. We need an instance to access it. So we would need to do something like book mybook equals new, and then mybook.title. But if I delete the static keyword, everything is fine. So why does it work, but it doesn't when print title is static? First, because both title and print title are instance members. So when we are referring to title from within print title, we are actually referring to this.title. I semi-explained what the this keyword means in a previous lesson, but basically it refers to the current copy of a book we are manipulating at a certain point in time. But for static, what this are we actually talking about? Because there is no this. This refers to a copy and static means blueprint, no copy at all. So when we are in a static member, we are in no copy at all. We are in the blueprint itself. Whatever is an instance member does not exist yet. It will only start existing when we create an instance, a copy of this book in the future, as opposed to the static members which will exist by the time we try to use it. So if static exists before instance, how would it access it? It can't. Therefore, you cannot access instance members from within static ones. On the other hand, accessing static members from within instance ones is perfectly fine, because by the time the instance member tries to access the static one existed long before the instance member did. So that's why we don't get an error when we try to use the static property stock from within the instance method cell. Notice how I always say static members. That's because static things can only be members of a class or struct. So properties, methods, fields, and events. You cannot have static local variables. But since C#8, you can have static local methods. We can also have static classes, something like this. And all the members of static classes also have to be static. So if I were to type the snippet for the constructor in Visual Studio, it is not smart enough to detect we are in a static class and generates a regular constructor. So we also need to mark it as static. But we still have an error that says product.product access modifiers are not allowed on static constructors. So we need to remove public. It cannot be private, public, anything. But know that static constructors are weird. First, you cannot call them yourself, ever. So you cannot do new book like you would with normal instance constructors. Second, the C# runtime decides when they actually ran. They are executed the first time you try to use that class. So either when you instantiate it, if it's the class itself is not static, or when you try to access any of its static members. And if you don't use that class at all, its static constructor will never be run. This behavior is called lazy initialization. The runtime waits and only executes static constructors if and when a class is needed the first time. So it's not like it's executing them at the program startup or anything. There is a nuance to it called before field init, and the rules are a bit looser when we are talking about types without an explicit static constructor, but I'll probably talk about that one in the video about the Singleton when I'll start making the playlist about design patterns. So you might want to subscribe if you don't want to miss that one. Third, static constructors only run once. That's why they are also called type initializers, because their job is to prepare that class before it's used. For example, initializing static fields or performing setup work that only needs to happen once, etc. Fourth, you do remember that for normal constructors we can add parameters and do validations like if title is null or white space, throw an exception, and etc. And in that case, we would not get an instance of that class, but we would have another chance to provide a valid value and eventually obtain a valid instance. But with static constructors, since they are called automatically, so you don't call them manually, and since they only run once, if an exception occurs in a static constructor, that type is practically unusable. Any later attempt to use it will result in a type initialization exception. Fifth, static constructors can't have parameters, so obviously they cannot be overloaded, which means you can only have one static constructor. A common usage for static classes, although frowned upon by some people, is what programmers call utility or helper classes, where you collect a bunch of useful methods that might not belong together, but doesn't really seem to fit elsewhere either. So for example, if you have a class called, I don't know, formatting utilities, where you store methods that need to be accessed throughout your program in many places without creating an instance, and you have methods like, I don't know, format country code, format phone number, format datetime, format, etc. Between static classes which cannot be instantiated and regular classes which can only be instantiated, we have a special programmatic construct called a singleton, which I previously mentioned, which is a class that can be instantiated but only once. So no matter how many times you try to instantiate it, you will have only one instance. And I'll dedicate an entire video to this concept, like I already said. If I won't forget when I'll make that video, the link will be in the description below. We also have extension methods which can only be declared inside static classes, but I'll explain those in their own video. We haven't learned about inheritance yet, but static classes cannot inherit other classes and other classes cannot inherit static classes, so inheritance is out of the table when it comes to static classes. Their members cannot be overridden, cannot be abstract, and a few other advanced topics that don't matter to you. Oh, and ever wonder why we have the static keyword on the main method? I already explained it in quite a few lessons already, that the main method is a special one. It is the execution entry point, is the one that is automatically invoked by the operating system when you double click on executable. So it does make sense why it's static, so it can be invoked without creating an instance of the class it lives in, thus being unique. Now there are a few advanced topics that I left out on static because this is a playlist for beginners and I'll probably make an advanced version of this video at some point, but for you as a beginner, probably the hardest question right now is where should you use static members, because you might read in some places that static is evil and you should never use it. Well, chill. If the thing should have never been used, the language designer wouldn't have added it in the first place. Instead, understand why it is not recommended to use static members and why you should use them with extreme care. Since they are allocated automatically, the garbage collector does not and cannot know if and when you are still using that static thing. So it's never deallocated. It sits in memory until you terminate the program. So if you are using, I don't know, static arrays, lists, etc. with a lot of data, that might become problematic. You might have memory issues and etc. Next, static means unique, like I already said, so the same for everybody, which means anyone from anywhere in your program can modify the same thing. So if you have a numeric variable with the value 101 and you expected it to be 100, who out of the 50 places that modify it throughout your program modified it? No idea. And I'm not even going to get into thread safety and stuff like that, that just makes it worse. Third, code that makes use of static methods with shared state or I/O is much harder to test. We will learn about unit testing at some point. This will make much more sense then. So, to answer your question of when should static be used, it depends. I mean, if you are developing a desktop or mobile application, that's a bit more static friendly, simply because a single user can sit in front of a computer or on a mobile application at one point in time. You certainly don't want to make a static discount variable on a website where it would be the same for all the users of your website. And my rule of thumb is, if it makes sense, use a static class or a static member. Like for example, when we are writing on the console, we have a single console, so it makes sense to use console.writeLine in this fashion. We don't need instances to access the same console. Another example could be, for example, logging, where you could have instances, but you can also access a logger to log stuff in a static fashion. It is usually the behavior that fits this static mentality, not the state. So usually when we talk about static, we are referring to functionality and doing something, not values and data. But obviously there are times when you do need static data, like we did with the properties, and if there really is no other way, my recommendation is to use a centralized assignment point, a single point where you assign values to these static properties or fields and only read them throughout your program. That's because if something is not right, you know where to go and put a breakpoint and see why that something is not right. Otherwise, if you assign it in 20 places, your grief will come from the deepest circle of Dante's Inferno, trust me. I'm talking from experience. Also for fun, you should know that you can use a using static directive, which allows you to import static members of a type into scope, not to be confused with a using alias, which is a shorthand name for a namespace or a type. So we can do something like this. And then we can do this. But I've rarely seen this one used only with system.math and assert, where you can call r=equal instead of system.assert.r=equal. Probably for a good reason. We are at the end of this lesson. If you are kind enough, hit the like and subscribe buttons, it really helps this channel to grow. For now, thanks for watching and I'll see you in the next tech frame.